Good morning, and thank you for joining us for today's webinar, Redefining End-to-End Monitoring, Dynamic Cross-Correlation, and Advanced Visualization. My name is Gia Mangino, and I'll be your moderator for today's event. Today's webinar is the fourth in our Redefining End-to-End series. The entire webinar series can be found on our website. Our presenters today are Mike Margulies, SL's Vice President of Sales, and Rodney Morrison, Vice President of Products for SL Corporation. Mike has been an enterprise software technology leader at some of the industry's leading firms, having held executive sales and marketing positions at both Oracle and VMware, and brings a wide range of practical applications, middleware, and infrastructure knowledge to the table for SL and its clients. As Vice President of Products, Rodney Morrison is responsible for product management, tracking market industry trends, as well as competitive analysis for SL. Rodney has had several roles since joining SL in 1988 as part of the development team, including technical sales support, managing software development, developing the VAR network in Europe, and managing sales and marketing efforts in Europe and Japan. Prior to SL, Rodney was a software development engineer and manager focusing on real-time embedded systems at Texas Instruments and E-Systems. Rodney holds a bachelor's degree in electrical engineering from the University of Kansas. Today's presentation will be approximately 30 minutes, with time left at the end to address questions from the audience. If you'd like to participate in the Q&A session, simply enter your question into the chat panel at any time during the event and click Submit. With that, I'll pass it over to you, Mike.
Thanks so much, Gia, and thanks everybody for attending today. This is the fourth of a four-part series on redefining end-to-end monitoring with RTView Enterprise Monitor. This topic today is going to be cross-correlation and advanced visualization, and follows the webinars that we've scheduled over the past several weeks and months about high-performance architecture and service model integration. So this is the last of our series. We appreciate you guys joining. Oops. Okay. As we discussed in each of the previous webinars, application architecture has evolved to meet the competing challenges of both being low cost and high power. And the result has been increasing complexity. Resource pools have become elastic to accommodate high growth in data and user bases. Physical resources are being subdivided into more and more virtual resources. All this is happening in the context of multi-tier real-time applications running across a disparate network of global data centers deploying multiple vendor stacks and needing to be up and running 24/7. So this is a much more complex world than it was even 5 or 10 years ago. And as you can imagine, managing applications and their health state has become more complex as well. So one of the most important things to keep in mind about application health is that in an environment where every second counts, and health state is really comprised of several dozen components performing well in concert, it's not a question of seeing every detail. It's actually taking details that are always available, more now than ever, and making sense of them, not being overwhelmed by them, enabling application health to be viewed holistically from 30,000 feet with correlated data and the ability to actually see, visualize the data that matter and the data that together illustrate health state. The problem with traditional monitoring and how it's evolved, focused on the infrastructure silos that are common in most data centers, is that it has no higher level view of the data that's monitored. Hardware, databases, app servers, VMs, organizations and teams have grown up around each of these computing silos, and for good reason. Expertise has often required specialization, and IT has been very adept at monitoring each of these specialized silos independently. But what's been missing from the traditional monitoring approach is the ability to see across these silos, to understand the interdependence across the silos, which pieces require which others to ensure application health, what an alert in one silo means when viewed alongside another, and how to find the source of a problem without really understanding how all of these pieces work together. And so what's needed is a way to do the hard work of normalizing the data, aggregating it, correlating it, analyzing it, and predicting and taking proactive steps with that data to address problems before they become problems. But traditional monitoring has imposed a brick wall over the silos, making it impossible to view those silos as part of an interdependent whole, and instead forcing it to kind of exist independently from the applications that the infrastructure is in business to serve. So what we've tried to do is define a new kind of monitoring, end-to-end monitoring, which differs from the older definition of sort of APM, digging down deeply into the code, into the transactions of the logs to see every granular detail. This redefined notion of end-to-end monitoring unifies data sources to promote 360-degree visibility across applications, represented at the top of the stack, and the IT resources that drive them, represented at the bottom. So real end-to-end monitoring allows for application and infrastructure level views, with complex access to real-time and historical performance and availability metrics, events, and trends. And the nuances of this data should be related and visualized in such a way as to enable people to see a large amount of data in very efficient ways. And that's essentially what we're going to be talking about today. So just to review real end-to-end monitoring requirements, which exist not only across tiers but across vendor stacks and across the enterprise, those requirements include a high-performance architecture that has to be distributed and cache-based to minimize latency. It has to include an integrated dynamic service model that can be auto-generated but user-validated and supplemented with several different sources. And lastly, sophisticated cross-correlations and visualizations, both application service-centric and infrastructure-centric views, and providing visibility into the data that matter by role, criticality, and severity. So that's what we're going to be talking about today and for the next 20 or 30 minutes. Before I turn it over to Rodney, I just wanted to review again the Enterprise Monitor architecture slide, because I think that it's relevant to what we're talking about here. EM has been designed from the ground up as a framework for monitoring across multiple vendor stacks and across the tiers in an enterprise for performance, availability, and flexibility. The data server layer, represented at the bottom, is architected to collect and locally process monitoring data and rules from any number of middleware and infrastructure sources. The source data itself is accessed agentlessly via an API and stored in caches for fast access, and then aggregated, normalized, and made available to the middle layer, the metadata layer, where a threshold and complex alert logic is applied based on the dynamic cache map that RTView maintains. In this way, we're able to slice and dice the information that's served up by role, by area of expertise, by focus, by criticality, etc. The relevant data is passed up to the EM server layer represented at the top, where service model integration and display logic is applied so that data can be viewed in a number of advanced visualizations tailored, as I mentioned, by role or domain. I also wanted to take a moment just to stress the importance of the in-memory service model that we help enable. Now, a lot of folks out there use CMDBs, and other people have other asset management systems and other information where some of this information, other repositories where this information is stored. Some people even use ServiceNow and other type of trouble ticket and help desk software that sort of augments the organizational hierarchy of the service model. But the service model is key for us because it associates the components that live underneath the applications with those services and applications themselves, and this happens both statically and dynamically. And it enables us to identify the service impact for an individual component problem. So if a piece of middleware is specific to an order management application, the service model helps us keep track of that. And the service model is critical for RTView because it allows us to impose the context, this real-world context, on the sea of alerts and events that we're dealing with across any number of configuration items, architectural components at any one time. Only by explicitly connecting those components, both physical and virtual, to the applications and services that they support can we really understand how to prioritize and increase operational efficiencies not only in the IT organization where people are tasked with triaging problems, but in general keeping applications up and performing healthily, which absolutely has an impact on revenue. So with that, I'd like to turn it over to Rodney to talk more about correlation and visualization in the context of RTView and end-to-end monitoring. Rodney?
Okay, thanks, Mike. So today I'm going to just talk about some of the, or just really a slice, a few of the features that are available out of the box in RTView Enterprise Monitor related to correlation and visualization. One of the main difficulties with analyzing problems that are affecting application availability and performance is that there are just too many differing points of information that have to be looked at to capture the system as a whole. And an advanced monitoring solution needs to correlate those items together that have dependencies, and then have advanced visualization techniques so that analysis can be performed quickly and then actions are taken. So to try to categorize the different areas of correlation and visualization that are available in RTView EM, I've categorized them first as the correlation of health by service. So that correlation is understanding how technologies are working and how healthy they are and how they affect a particular application or service. The second area I'm going to cover today is really looking at complex technologies that you're using and understanding how those are performing well together with their different moving parts, and also how well they are performing in load balanced situations. And finally, I want to talk about correlation between instances of those technologies and how they rely on other technologies or resources to perform well. So today I'm going to go through first several top-level views that you can look at to understand how your services are performing. And just to give you an idea of how a typical workflow works, you're going to look at one of those high-level business impact summaries, those overview displays, and from that you can identify a service of interest and drill down to view component dependencies. So what does that service depend on? How well is that performing? And then finally, when you identify some component, or maybe multiple components that aren't performing well, you can then drill down and analyze why with historical data about how that specific component is serving your application. So the first sort of overview I want to look at or analyze here that we provide is called our Application Service-Centric Heatmap. And to describe how it's used, well, actually what it does is it provides these boxes there that are larger or smaller depending on the complexity of the service itself. You know, how many hosts it's using, how many, is it using a message broker, how many queues does it depend on. The larger it is, the more complex it is. And then you'll see we give a color, and not just red, green, and blue, but it's like a rainbow color that tells you, is there impact here? Do I care about that service? And so it does an aggregation both of the alert state of various components, but also the criticality of those components and the criticality of the service itself. Why is this interesting? Well, let's take it from the operations perspective. You might have hundreds of events that you're trying to figure out how do I deal with. One of the easy ways to figure out what's important is to look at this top level of the screen and say, this is impactful to my business. These are the ones I want to manage and handle first. Now, the ops teams don't often know exactly what the app is doing, but they know they need to handle the underlying infrastructure issues so that it can perform well. From an app team perspective, he's just getting a view as he logs in of the apps that or services that he cares about or he or she cares about. And that way, just in a quick glance view, say, is there anything I need to worry about? From these then boxes, you can drill down to look at detail to analyze the problem. Another, and this is very similar information, is just whether you want to see it in tabular views or you want to see it in heat map views. And the difference being, in many cases, you've got, or some organizations have 20, 30, hundreds of services that they're in their domain to watch over. And when you look at it in a table view, then you have to scroll up and down or look at different groups to filter them to figure out what's important. And on the heat map, you can look at hundreds of screen real estate. You can look at hundreds of things and see if there's any area. Perhaps I have a trading system that has 4 services that are in critical state, and that can help you prioritize things. But the tabular view here on the left-hand side shows the aggregated view, which says all CI types, service name on the side, Is it in a problem state? And then the supporting technologies that are used or monitored by that particular service. So you can say, for example, on the online store service here, it's in a critical state. Looks like I've got a problem on the host. I've got some warning situations on my Weblogic server or the apps that are running on that server. When I click on that online store there, I also see below it the related alerts or events that have happened here. So I've got the most important one is the memory usage high on that host. A really unique view here that I don't see very often in any monitoring solutions is the history of the performance of a service. So just to describe how this one's used first, let's look at the right-hand side. Those are all the services that you're monitoring or looking at their performance or health, and the bubble next to it says what's its current state. Is it green? Is it red? Is it orange in between? But what it shows on the left-hand side, and you'll see the time axis on the bottom, is how is it performing over time. And so I can then look at it, well, this service has been green, but it goes red at these particular points in time. And why that's interesting is oftentimes you've got different periods where load is high for users, or you've got different periods where there's other situations that happen in a periodic time. And so when you're looking at it just the current state all the time, you don't catch those things. And you want to be able to uncover, okay, this is a situation where if I want to handle these peak situations, I perhaps need to increase my resources. So that way you can look at history over time. It's important for both the app support teams and operations to realize that there's situations going on in a periodic fashion that we need to deal with. From any of these summary screens, so like I talked to you before, I've got a service that I've got an issue about. I can drill down and then look at that particular service. I can do analysis on the components that are having a problem. In this case, there is an EMS message broker service that is having difficulty supporting this service, and I can click on it and look at any events that are happening on that service. From that, then you say, okay, I need to analyze that, what's going on there. So I drill down to the specific EMS server itself, and I can uncover, yes, I've got high pending messages issues here. I can look at, is it related to message traffic in and out? I can look at producers and consumers. Are those the ones I assume are going to happen there? And then drill down and analyze the actual situation. So on to the next category of types of correlations that we do, and this really gets into the more complex types of technologies that you use within your application stack. And these technologies have a lot of moving parts and dependencies, and you need to understand how those dependencies are correlated and then present those performance metrics using those correlations to quickly understand the system as a whole. And I'm just going to go over three types here, though we have many in our different solution packages. We're going to look at Oracle Weblogic today, though we have other solution packages for other app server technologies, TIBCO Active Matrix, which is the orchestration platform, and Oracle Heron's Data Grid. So first, let's look at the advanced correlations and visualizations we have for Weblogic. And with Weblogic or any app server, really, there's many dependent parts that have to be correlated and analyzed to understand how it's supporting your applications or services. You've got the WebLogic server itself, WebLogic domains, applications running on those servers and how they're clustered, and also how sockets, thread allocations, JDBC connections, JVMs, CPU, and memory consumption are affecting those apps being served in that server. In addition, there's also complexities of correlations about destinations and consumers of messages and balancing message loads. So trying to determine whether a service is healthy with all these many dependent moving parts is hard to do when you have to correlate all those in your head and look at independent performance metrics for each piece. And let's say, for example of WebLogic, you're just using the WebLogic admin. That's what you have to do. You have to go to each piece, look at the metrics, correlate them in your head, and figure out, do they interact? And so within our solution package, we strive to understand those types of problems, really present information to you that is relevant to solving problems, rather than just leave that as an exercise for you. So today, I'm just going to pick one. There's many features of our Weblogic solution package, but this is just one, and it helps you determine if clustered applications are load balanced properly. So here we have a correlation view where we show a particular application that's in a load balance cluster. And just at a glance, you can see the aggregate values for this application. So you can look at the top left stack bar charts and understand open and new sessions for that app and invocations for that app, and look at it over history at the bottom. Those are the aggregate totals. But in addition to that, on the top right side, you see a heat map there, and it shows you there are 24 clustered instances there that are load balanced and are performing that service. And I can see if they're all sort of around the same color, it's load balanced. If they're disparate, one's red, one's blue, they're not load balanced. And just anecdotally, we install this in many systems, and oftentimes I had no idea that this wasn't working. I had no idea that this particular instance wasn't even running at all, or is not load balanced properly. And that's stuff that's really difficult to do or uncover if you're just using sort of admin tools to look at those disparate metrics individually. Move on to another, and this one's kind of similar. Typical Active Matrix is a platform for deploying composite business processes and SOA-oriented applications. And what happens is the users can deploy various services and then load balance those services by providing multiple nodes that are load balancing that service. And you can either just define how many nodes are in a service, or sometimes those dynamically are created based on load so that you can handle peak loads. And what this shows is that you've got one service, and you've got the aggregated hits and response times for that service, but in the top right, this particular service has two nodes, and it breaks it down for you to let you know whether they're distributed or not. And that's an important thing when that's one of the main features you're trying to gain out of this SOA platform. The last one I want to talk about, a sort of a complex visualization and correlation, is looking at the coherence data grid. And actually, this one is a popular one with developers, not even just app support teams and ops. And the issue is that they've got a variety of caches that are supporting services. And in this example, each strip, as you look across from left to right, each horizontal strip is a cache, and they interact with each other. So you need to understand quickly with various metrics, such as looking at gets, puts, failures, and that sort of thing across the caches. Are they interrelated and in a time slice? So as you're looking left to right, this is a time slice. So I can see hotspots really quickly where one cache is related to another, and we're getting misses on both of the caches, for example. And imagine trying to analyze this with a series of trend charts that show the particular metric for all of these different types of caches together. So this is a really popular one in development situations because they often can discover where they've misconfigured their applications or the coherence data grid itself. All right, I'm going to go now to the last category of correlations and visualizations, and that's where we're doing cross-technology correlation. Where do technologies rely on other technologies or resources to perform well? And I'm going to look at just two examples here. One is from a web app perspective, where we can correlate WebLogic servers, the apps that are running on them. They're using a coherence data grid for data storage and access, and the hosts that they're running on. And the second example, I'm going to cover how Oracle coherence data grids are correlated with the host and network resources that are critical to the operation of that grid. So first, let's look at a top-level view. This is the one where we're looking at cross-technology performance gathering related to web apps on WebLogic servers. And this top-level view is showing a load-balanced service which has 24 different instances of an app running that are load balanced, and then across the top, and then the dependent services or components of that in a vertical stack. To see that a little bit more clearly, I'm going to zoom in on that piece here. So I can look at, for example, OLS App 2. That's one of the applications that's load balanced. I can see the new sessions and open sessions that are happening with those different instances, invocations with those different instances. But also, right in a row, in a horizontal view, I can look and see what are they consuming as far as CPU usage, server memory usage. Right in that same view, I can see their impact on coherence, what are the gets and puts and the cache sizes that are available. And then right on down the line, I can see, okay, and here's the impact of the actual host resources, whether it's a VM or a physical host, of CPU, memory, and network usage. Really critical in understanding how those things are put together, that you'd have to look at a variety of different tools even, or different trend charts you're looking to try to correlate all those things together. Okay, here's sort of the last area I'm going to look at today. This is cross-technology correlation, and it's correlating coherence services or nodes and the resources that they're going to consume, whether it's hosts or network. So from a coherence perspective, there might be a lot of issues of how you've constructed your data grid, how the services are using them, which are affecting performance, and we can provide you that information. But sometimes, well, in reality, those nodes require physical hosts, resources to operate on, as well as network communication between those nodes for the grid to work properly. So this is one view that shows the important service metrics at the bottom of the page, so I can look at messages between the service and various activities of the services. And then I can look at the top in a time slice view to say, okay, what is it using as far as the resources of the host? So here's where you can discover I've got a misconfiguration problem, I've got a load problem, when you've got a lot of activity on a service and it's maxing out the host. But you know what it also can show you is these services aren't doing anything. And look, I've got maximum loads on these hosts and somebody's hogging it, and it shouldn't be that way. Similarly, I can look at it from a network perspective, so I can look at the various nodes at the bottom of the screen over time and look at a time slice and look and see, okay, these nodes are sending this packet load, and here's how it's consuming network resources at the top. Similarly, I can look and see, yeah, we've got a load problem that's inherent just in how we've constructed the data grid, or I could see, there's not much network going on between the network communication going on with these nodes, yet somebody is hogging my network. So just in summary, I want to say that without correlations and visualizations, you're left with really a bunch of disparate metrics, sometimes from different tool sets, where experts must perform those correlations of dependencies themselves and try to visualize them and analyze it to determine application and technology health. And we spent a lot of effort working with development and support teams to really understand the usage of those technologies in complex application stacks, uncover the key stress points and dependencies that must be analyzed, and find the most efficient way to do that. So today we just looked at a few examples within the RTView Enterprise Monitor in the areas of service correlation in complex technologies that have many moving parts, and correlation of technologies working in concert with other technologies or shared resources. So with that, I'm going to hand it back to you, Mike. Thank you.
Thanks so much, Rodney. And thanks, everybody. I just wanted to go through one or two more things before we conclude. Just by way of summary, I wanted to touch upon some of the functional imperatives that this new kind of end-to-end monitoring is ushering in. We discussed in the last several webinars, and I'll just stress it again here, the need for a high-performance architecture, an architecture for your monitoring system that can keep pace with your actual applications. So for low latency applications, high-performance applications, you need a monitoring system that can take time slices in as fine-grained a manner as is required to provide sub-second or single-second response time and metrics for that to predict any kind of performance issues or availability issues. Secondly, we have an integrated and user-defined service model that's instantiated in memory, so it's very fast. It takes advantage of a number of different facilities and integrates those facilities via the service model into the RTView system and enables slicing and dicing by role or by application area or by service. And lastly, what we talked about today was cross-correlations and visualizations that leverage the service model, but that provide views based on application or infrastructure-centric information and provide visibility to the data that matter, rendering the complex simple and allowing you to prioritize and classify activities and importance of all of these events. We have many customers across several different verticals that have been with us for quite some time because we are the de facto leaders in middleware monitoring, and we are the only solution really that provides the value of correlating with service model integration, multiple vendor monitoring targets, and providing some level of coherence across all of these different disparate sources. All of these customers continue to come back and acquire new software from RTView as they expand their footprints. They're moving into areas that are new areas that we provide monitoring solutions for example, Solace, messaging appliances, or open source systems like JBoss or MySQL, or other types of components that individually there are many, many different solutions for, but taken as a whole underneath sort of an application-centric view, what we need is some way to incorporate all of these technologies into a single framework, and that's exactly what Enterprise Monitor is designed to do. For more information, you can visit us at our website, sl.com, where you can request a demonstration, start an evaluation, download collateral, watch a video, inform yourself about what it is that we're doing and some of the news that is relevant to monitoring and to SL Corporation and RTView. And we'd be happy to answer any individual questions that you might have offline or in the next few minutes when we're going to open up the lines to individuals. And Rodney and I will be happy to take questions. Thanks, everybody, for your attention. And with that, I'm going to pass back to Gia, and she's going to manage the Q&A section.
Well, thank you very much, Mike and Rodney. At this time, I do have two questions here. The first, in addition to having visualizations to do analysis, can you be notified when these correlations find a problem?
I'll take that one, Gia. Yes, absolutely. I didn't cover that today, but we have many built-in rule alerts that you can set to indicate when you want to do these kinds of analysis, or you've got a service problem or a technology problem. Those are built in. But you can also create your own rules. So maybe you have some specific types of situations that are maybe cross-technology in nature that you could put together complex rule sets to define, okay, this situation's happened again, and I need to look at the correlation and analysis screens.
Thank you, Rodney. One more question. Can you create your own custom correlation views?
Yeah, you might, because you might notice these are actually quite rich and quite different than most of the monitoring systems that you'll look at as far as the richness of them and the way we can correlate different information together. And the answer is yes. So we have a whole sort of platform that you can create these custom dashboards yourself if you have some specific types of correlations or visualizations that you want to do for your environment.
Okay, well, thank you very much, Mike and Rodney. Unfortunately, we're out of time. Thank you to the audience for your questions. Just a reminder that this webcast has been recorded, and we'll be emailing a link to the recording within the next few days. Thank you for joining us, and have a great day.
Thanks, everybody. Have a great day.